Now, each of the problems in this example have a radical of a fraction, and directions on this would be something along the lines of use the quotient rule to simplify. And so if we're going to use the quotient rule tells us we can rewrite this as the square root of 25 over the square root of 49, which is simply 5 over 7. And we've really already taken square roots of fractions. We're just sort of explicitly saying now that this rule is okay. If we do the same thing to the second problem in this example, then we're going to have the square root of x on the top and the square root of 9 on the bottom. Now we don't know what the square root of x is, so we're going to have to leave that in the top. But as far as the bottom, we do know what the square root of 9 is, which is 3. And I want to include this example to point that out, that we could start off with a fraction and be able to take the square root of one of them and not the other, and that's perfectly fine. And so we get an answer that has a radical in the top, but not in the bottom. And that's okay. We can also move this up to cube roots. So the same thing's going to apply, that we can take the cube root of the top and the cube root of the bottom separately. And as expected then, cube root of 8 we know is 2, cube root 27 we know is 3, and we get a value. And we could press forward and do the same thing with a fifth root. We could write this as the fifth root of 3. Now on the bottom we could take the fifth root of all of that, but also remember though that we had the product rule that says I can take the fifth root of the 32 and the fifth root of the x to the fifth separately as well. Now up top, the fifth root of 3, we don't know. The fifth root of 32, if we look to our powers chart, is just 2. And the fifth root of x to the fifth is just x. And so remember that once you take a radical, the radical sign goes away. So we took the fifth root of x to the fifth, no more radical, it's just x.